Okay, so question 5 is going to be about reflection and refraction. A student is investigating refraction. We can see that there. We've got the apparatus and the angles to be measured. So we've got theta I here, the angle of incidence. Got the angle of refraction there, theta r. And they measure the angle r for different angles of I. So they're going to change this angle, shine it in and measure r. And it says use the graph to estimate the value of angle r. So our first job is, let's draw a line of best fit. There we go, we can see it's a curve. Next one, we're going to go and find 80 on the bottom for theta I. So angle I is 80, that goes up there. And I've got a measure of about 42 degrees. I think it says anywhere between 41 to 43, I think. But you can see that that's a curve. So 42 degrees. Describe how angle R changes with angle I. So we can see as angle I increases, angle R increases, but it's non-linear, it's a curve. So as I increases, R increases, but it's a non-linear relationship. And the next part is the frequency of the light remains the same in glass as in air. Which row describes what happens to the wave velocity and to the wavelength? So if I go back to this diagram here, we know that as it goes from air into glass, that it's going to slow down. And as it slows down, the waves will bunch together. So if we know that there, they'll bunch together and then they'll go out as they came in. So we've got this basic idea that you're going to slow down, the waves will bunch together, so the wavelength will go less. So speed will go down, wavelength will go down, and that's going to have to be A, decrease, decrease. On to the next one. Figure 7 was only refraction of light. Other things happen as it travels from P to Q. The intensity of the light at Q, so here, is less than it is at P. Okay, that makes loads of sense. Explain the decrease in the intensity. Well, the first part is we're not just going to get refraction, we're also going to get some light reflected off the surface. Mark. As it meets this boundary of the two different densities. The other part is this glass is going to absorb some light and convert it to some heat energy. So we just got to put that into words. So some light will be reflected from the front surface, that is as we go from air to glass. And some light will be absorbed by the glass as it transmits through. And there we go. Which of these sketches represent the speed of light as it travels from P to Q? So if we just go back, I'll get rid of all of the doodles. So what we're looking for, well, it's going to have the same speed here as here. So we need it to have the same speed in as out. And we're looking for it to slow down as it goes through the glass. So we're looking for something that makes sense. So, well, not that one because it's not going back to its starting speed. It can't be this one because it hasn't gone back to its starting speed. So it's a choice of these two. And this one says the speed increases. That's garbage. So it's got to be B. And that's it for that question.